What if consciousness is not created by the brain at all? What if your thoughts don't originate in your neurons, but somewhere far deeper? What if the mind is not a biological accident, but a cosmic phenomenon? What if the soul is not a belief, but a physical trace of the universe itself? And what if everything we think we know about self is fundamentally incomplete? For decades, modern science has explained consciousness as a byproduct of neural activity. Electrical impulses, chemical signals, billions of neurons firing in complex patterns. According to this view, the mind is what happens when the brain becomes sufficiently advanced. No mystery, no soul, just biology. But there is another possibility. Some physicists and philosophers argue that consciousness cannot be fully explained by classical physics. They suggest that the mind may be connected to the quantum fabric of reality itself, that the brain could be less like a generator and more like a receiver. If that's true, consciousness may not end at the skull. It may extend into the very structure of the universe. If these questions intrigue you, leave a comment with your thoughts, like the video to support the channel, and subscribe. Because what we're about to explore may challenge everything you believe about the mind. According to modern neuroscience, consciousness is not a mystery hidden outside the brain. It is an emergent property, something that arises naturally when matter becomes complex enough. The human brain contains approximately 86 billion neurons, each connected through thousands of synapses. These cells communicate using electrical impulses and chemical messengers, forming vast networks of information flow. Thoughts, emotions, memories, and decisions are believed to emerge from this continuous signaling process. From this perspective, consciousness is not a separate entity. There is no independent soul floating above the brain. What we experience as awareness is simply the brain monitoring, integrating, and responding to its own activity. Neuroscientists often compare the mind to software and the brain to hardware. Just as software emerges from electronic circuits, the mind emerges from neural circuits. Damage the hardware and the software changes. Alter the brain and consciousness is altered as well. This view is strongly supported by clinical evidence. Injuries to specific brain regions can erase memories, change personality, or disrupt self-awareness. Neurochemical imbalances can induce hallucinations, depression, or euphoria. Anesthetics can switch consciousness off entirely, and back on again. To neuroscience, these facts suggest a clear conclusion. Consciousness is what the brain does. Nothing more, nothing less. Yet even within this framework, a troubling question remains. If consciousness is merely the result of neural activity, why does it feel like something to be conscious at all? Modern neuroscience can explain how the brain processes information. It can describe how neurons fire, how signals travel, and how decisions are formed. But there is one question it still cannot answer. Why does any of this feel like something? This is what philosopher David Chalmers famously called the hard problem of consciousness. Not how the brain works, but why subjective experience exists at all. A brain can detect light, process sound, and calculate outcomes. A machine can do the same. Yet only conscious beings experience color, emotion, pain, love, and meaning. Neuroscience can map neural activity when you see the color red. It can identify which regions activate, which neurons fire, which chemicals are released, but nowhere in that data do we find the experience of redness itself. This inner world, sensations, thoughts, feelings, is called qualia, and qualia cannot be measured, weighed, or observed from the outside. They exist only from the first-person perspective. This creates a profound gap. No matter how detailed our brain scans become, no equation tells us why electrical signals should produce a sense of self. No neural diagram explains why awareness feels personal, unified, and continuous. This is where the materialist explanation begins to weaken. If consciousness were merely information processing, then any sufficiently complex system should be conscious. But complexity alone does not guarantee experience. Something essential seems to be missing from the equation. And it is at this boundary, where classical explanations fall silent, that alternative theories begin to emerge. When classical explanations reach their limits, scientists look deeper, not outward, but downward, to the most fundamental layer of reality. Quantum physics governs the behavior of matter at the smallest scales. At this level, particles do not behave like solid objects. They exist as probabilities, not certainties. They can occupy multiple states at once, influence each other across distance, and collapse into a single outcome only when observed. To some researchers, this strange behavior feels uncomfortably familiar. Consciousness, too, resists precise definition. It cannot be isolated, copied, or directly measured. Like quantum systems, it seems to exist somewhere between potential and actuality. This has led certain physicists and philosophers to ask a radical question. What if consciousness does not emerge from matter, but instead arises from the same fundamental principles that govern the universe itself? If reality, at its core, is probabilistic and observer-dependent, then awareness may not be an accidental byproduct of biology. It may be woven into the structure of existence. From this perspective, the brain is not a classical machine. It is a biological system operating at the edge of quantum possibility, where uncertainty, superposition, and collapse might play a role. This does not mean that every thought is a quantum event, but it suggests that classical neuroscience may be missing something essential. At the deepest level, the universe is not made of solid things, but of relationships, probabilities, and information. And if consciousness is part of that foundation, then understanding the mind may require understanding reality itself. If consciousness is not fully produced by the brain, then the brain itself may need to be redefined. Instead of a generator, some researchers propose that the brain functions as an interface, a biological system that interacts with a deeper layer of reality. A useful analogy is a radio. A radio does not create music. It receives invisible signals and translates them into sound. When the radio is damaged, the music becomes distorted, but the signal itself does not disappear. In this view, the brain does not generate consciousness. It tunes into it. Neural activity would then shape, filter, and personalize awareness, rather than produce it from nothing. The self you experience would be a localized expression of something more fundamental. This idea may sound speculative, but it addresses a problem neuroscience cannot escape. Destroying or altering the brain changes consciousness, yet this does not logically prove that the brain creates it. Damage to a receiver affects the signal you hear, not necessarily the source of the signal itself. If consciousness exists at a deeper level, possibly connected to quantum fields or fundamental information, then the brain may act as a biological boundary between the universal and the personal. This would explain why consciousness feels both deeply individual and yet strangely connected to something larger. Under this model, the mind is not confined to the skull, it is constrained by it. And that raises a difficult but unavoidable question. If the brain is an interface, what exactly is it interfacing with? In the 1990s, a controversial idea entered the consciousness debate. It came from an unexpected collaboration between a mathematician and an anesthesiologist. Roger Penrose, known for his work in mathematical physics, and Stuart Hameroff, a specialist in anesthesia and brain function, proposed that consciousness cannot be explained by neural activity alone. Their theory is called orchestrated objective reduction, or OR. According to this model, consciousness does not arise solely from neurons firing. Instead, it originates inside structures called microtubules, tiny protein scaffolds within neurons that help maintain their shape and function. Penrose and Hameroff suggested that these microtubules may support quantum processes, not random noise, but organized, orchestrated quantum computations that collapse into conscious moments. In this view, the brain is not just processing information, it is coordinating quantum events at a microscopic level. Each conscious experience, they argue, corresponds to a moment when a quantum state collapses in a specific, non-random way, guided by the structure of space-time itself. If this is correct, consciousness would not be an illusion created by complexity. It would be tied directly to the fundamental laws of the universe. The mind, under OR, is not separate from reality. It is embedded within it. This idea reframes the concept of the soul, not as a supernatural entity, but as a natural phenomenon rooted in the deepest structure of existence. Yet extraordinary claims demand extraordinary evidence. And this is where the controversy begins. Despite its appeal, the OR theory has not convinced most scientists. In fact, the majority of neuroscientists and physicists remain deeply skeptical. The main objection is a practical one. Quantum effects are extremely fragile. They typically occur at near absolute zero temperatures and collapse instantly when disturbed by heat, noise, or interaction with the environment. The human brain operates at around 37 degrees Celsius, a warm, wet, and chaotic biological system. Under such conditions, maintaining coherent quantum states appears highly unlikely. This problem is known as decoherence. According to critics, any quantum activity inside neurons would collapse far too quickly to influence cognition or awareness. In their view, classical neural processes are more than sufficient to explain conscious experience. There is also the issue of evidence. While microtubules are well studied biologically, no direct, repeatable experiment has demonstrated large-scale quantum computation occurring within them. If consciousness truly depended on quantum processes in microtubules, scientists argue we should be able to measure its effects by now. Some researchers go further and claim that invoking quantum physics is simply a way to avoid admitting ignorance. When an explanation feels incomplete, adding the word quantum does not automatically make it deeper. From this perspective, OR remains an intriguing hypothesis, but one that sits closer to philosophy than established science. And yet, even with these objections, the hard problem of consciousness still stands unresolved, which raises an uncomfortable possibility. What if the skepticism itself is premature? Some researchers and philosophers take a radically different approach. They argue that consciousness is not something the brain creates, but something the brain accesses. In this view, consciousness is fundamental, not an emergent byproduct of matter, but a basic feature of reality itself, like space, time, or energy. The brain, then, is not a generator. It is a filter, a system that limits, focuses, and personalizes a much broader field of awareness. This idea helps explain a long-standing paradox: why consciousness feels deeply individual, yet universally recognizable. Your thoughts are yours, your memories are unique, but the fact of being conscious, the feeling of awareness itself, is shared by all. Some theories compare this to an ocean. Individual minds are waves, distinct in shape and motion, but never separate from the water beneath them. Under this model, consciousness does not begin at birth, nor end at death. What changes is the structure that shapes it. The brain gives form to awareness, but it does not own it. This perspective resonates with modern physics in an unexpected way. At the deepest levels of reality, fields matter more than particles. What we experience as solid objects are excitations of underlying fields. If matter emerges from fields, why not mind? Perhaps consciousness is not produced by the universe. Perhaps it is how the universe experiences itself. One of the most unsettling questions in the consciousness debate emerges at the edge of life itself. What happens when the brain shuts down? People who have been clinically close to death often report strikingly similar experiences. A sense of leaving the body, moving through darkness, encountering light, or feeling an overwhelming unity beyond the self. Neuroscience explains these accounts as hallucinations, the result of oxygen deprivation, neurochemical surges, and a brain struggling to maintain coherence. But from a different perspective, these moments raise a deeper question. If consciousness is filtered by the brain rather than created by it, then what happens when the filter fails? Some theories suggest that in such moments, awareness may temporarily detach from its biological constraints, not disappearing, but returning to a broader field. There is no definitive proof of this, but the persistence of these experiences across cultures and eras keeps the question alive. This debate becomes even more urgent in the age of artificial intelligence. If consciousness is merely the result of complex information processing, then a sufficiently advanced machine should eventually become conscious, not simulate awareness, but possess it. But if consciousness depends on something deeper than computation, something tied to biology, quantum processes, or fundamental reality, then no machine, no matter how intelligent, may ever truly experience a sense of self. A machine might say, "I am conscious," but would there be anyone home? This forces us to confront a final boundary. Is consciousness something that can be built, or something that must be tuned into? And if one day a machine claims to have a soul, the question will no longer be theoretical. It will be ethical. Throughout this episode, we explored two radically different views of consciousness. One sees the mind as a product of biology, neurons firing, signals flowing, complexity giving rise to awareness. The other suggests something far deeper, that consciousness may be woven into the fabric of reality itself. We examine the limits of neuroscience, the unresolved hard problem of subjective experience, the controversial role of quantum physics, and the possibility that the brain is not a creator, but an interface. None of these ideas are final. None offer a complete answer, but together they reveal something unsettling. The more we study consciousness, the less certain we become about what it truly is. If awareness is fundamental, then the universe may not be as silent or indifferent as it seems. And if the mind is more than matter, then the boundary between self and cosmos is far thinner than we imagine. In the next episode, we turn our attention outward, beyond the mind, beyond the earth, to a mystery that echoes the same question on a cosmic scale. If intelligent life should exist elsewhere in the universe, why haven't we found it? If this episode made you question what it means to be conscious, leave your thoughts in the comments. Support the channel by liking the video and subscribe. Because the answers we seek may be hiding where we least expect them.